In this video, we're going to work out the surface area of a cone. So the equation for this straight line here is given by this. So this bit here corresponds with this one here. So when we rotate this 360 along the y-axis, it will sweep out a cone like this. When you rotate it 360, it will sweep out a cone, and then this cone here is this cone here. So we are going to try and work out the surface area of this cone here. So from high school, the surface area of a cone. Remember, we are not concerned with the bottom part of this cone here. We are not concerned about the bottom part of this cone. We only care about the surface area on top. Okay. So from high school, the formula for the surface area would be this. So that would be 2 pi r. But when you come and look at this particular cone here, the radius here is 1. So r here in this case would be 1. So it would be 2 pi times 1. Okay. So these two would cancel each other out, and then the slont height is u using Pythagoras. So this here is from here to here is 1. So it's using Pythagoras. So this here is 1. So the hypotenuse here is root 2. Okay. So from high school, the surface area is given by pi times root 2. So our method should later on give us the same answer, pi times root 2. But the thing is, this here is our formula for working out the surface area. But this formula won't work in this case, because when you look at this, when we were using this, well, this bit here gave us an arc length. So remember, we were doing it along, we were summing up everything along here. The thickness associated with this particular slice here would be dx. So when we were doing this bit here gave us the arc length, and then we would times the circumference, and then we would times the circumference. So this bit here was our radius. So when you 2 pi r, well, f of x would give us from here to here, the height here, and then when you 2 pi r it, you're rotating it along the x-axis. But the thing is, in this case here, we need to do it along the y-axis. So we need to somehow work out this length here in the x direction, and then rotate, and then 2 pi r it in the x direction. You see, this f of x here gave us the height, and when you 2 pi r it, you're going to get a circumference in this direction. What we need to do is we need to work out this length here, and then 2 pi r it. So it would be in this direction. Okay, so hang on. So hang on. So normally when you normally when you have a function like this, this width here is delta x or dx. Okay, so you would start with your dx here. You would start with your thickness here, and then the minute you times f of x, that then gave us the area. Okay, that then gave us the area, and then we would sum up everything. But our old way of doing it, we would start out with dx, delta x, or it could be dx. So we would start out with this. The minute you times this bit here, the combination of the two would represent a length, a one-dimensional length. This here gave, when you start out with your dx here, the minute you times this, it would give you the area. So this here gave us an area. This here, the combination of the two here, would give you a one-dimensional length, and then you would 2 pi r. Well, in this case here, r would be the f of x here. So by you doing this, you are really creating a circumference in this direction. But when we come to do it, hang on. But in our case here, we need to rotate in the y direction. So we need to do it like this. So hang on. You see, our old method here wouldn't work. Because we need to rotate it along the y-axis. So to do this, hang on. So to do this, we would sum up everything here in the y direction. So we would need to sum up everything from 0 to 1, and then it's going to be something dy, because we are summing up everything. We are moving in the y direction, so we need to sum up from 0 to this something dy. Okay, and then let's just look at this one particular slice here. The equation for this line here is given by this. But the thing is, when we 2 pi r it, we need to do it in this direction. So we need to know the length in the x direction. So don't forget, as we're summing up everything, y is moving about. So 1 minute, this here could be 0.2. This here could be 0.5. Y is moving about. If you want to know the x direction, if you want to know the length in the x direction, you would need to well, the length in the x direction here would be would be y plus x equals 1, x equals 1 minus. So the length in the x direction would be 1 minus y. Okay, so what we need to do here is we need to sum up everything from 0 to 1, and so it would be something dy. Okay, but then this bit here, well, we need to work out the arc length, and then we need to 2 pi r it. We need to 2 pi r it. But the thing is, r in this case, the radius in this case is really this thing here. Don't forget, it is y that's moving about, but the radius in this case is given by this, so it would be this. So this here would be our radius. So y is moving about. No matter where y is, you put it into here, and it would give you, this thing here would give you the radius, and then we would 2 pi r it. So this bit here would give us the circumference in the y direction. So when you rotate it along the y-axis, this thing here would give you the circumference. I will continue in the next video. So from here we need to times it with the arc length, but I will continue in the next video. Okay.